computer. Yes, so we're now recording, and I will share my screen with you so that we can get started. I hope you can all see this slide. I can see it. Yeah. I should just say I'm Rainer Meyer, just to introduce myself. I've run an energy consultancy for the last 30 years, but previously I've worked for BP Research, amongst others, and collaborated with various universities, University of Reading, University of Cambridge, and University of the West of England in this area. So here we are, potential of renewable energy sources. This is just to remind you that there are many different types of renewable energy sources, of which the one that we're most interested today possibly is the ground source heat pump, for reasons that we'll describe in a minute. So the question is, which renewable sources for heating our homes? And these are just, the bullets I think are self-evident, but the reason for wanting to go to renewable energy sources is not only are they abundant and renewable is their title, but they have little environmental impact compared with fossil fuels. Solar thermal and solar electric provide hot water and electricity, but peak primarily during the summer months. So it's not much help if we require heating in the winter. Wind peaks during the winter, but is very variable and is not strong usually in urban areas due to trees and high-rise buildings and this sort of thing. But the great advantage of heat pumps is they concentrate, they don't produce, they concentrate the ambient heat present in the air, ground, or water at any time of the year, and can use solar electricity if available. I'll go to the next slide, and then we'll just stop to see whether there are any questions, because this is the sort of one which you could well say. And this is important, what's written here, why heat pumps are more efficient than gas boilers. They concentrate the ambient heat, and therefore these sources are reduced during the summer months when we don't need heating. And we've proved this at the University of Reading, where we have ground source heat pumps heating the student services building, with the installation's been in for 15 years, and the heating, ground source heating is used during the winter, and during the summer, heat flow through the fractured chalk layer renews the heat. So therefore the efficiency hasn't dropped in the 15 years that it's been operating. And the other great advantage of heat pumps is that they can provide up to 4 units of heat output for each unit of electricity, can provide both space and water heating. This is the greatest use of energy in the home. And they're already installed in 10% of the EU housing stock. The technology is not new, first developed 200 years ago. So it isn't as if it's a new technology. It's been around a long time. It has been refined and efficient. John, are there any questions at the moment?
No.
No, none at the moment, right? So you all know everything about heat pumps. Good. Now this is a key slide, and you need to understand this if you ever want to consider using heat pumps. And that is that heat pumps operate continuously rather than intermittently. Gas boilers, as you most probably will know, switch themselves on and off, but heat pumps operate continuously. So in Scandinavia, you switch your heat pump on in September and you don't switch it off till April. So they're running 5,000–6,000 hours a year. And modern heat pumps can do this. They have very good life and they work very efficiently. But what is critical to their installation is their cost is related to size. And therefore, the smaller the heat loss, and I can't emphasize this enough, the smaller the heat loss of the dwelling, the lower will be both the purchase and the installation costs. And this is absolutely critical in terms of doing it. We'll come back to what the optimum size is later on in the slide set, but it is only cost effective if you insulate first and then install a heat pump. There's no other way of describing it. And there is a greater question, and that is that the renewable source, be it the heat and the ground and the air, needs to be equitably shared. And this is only possible if the heat loss of the dwelling is sufficiently small so that it can be shared. Otherwise, there is not enough either heat in the ground or enough heat in the air to be able to do this. So there are a number of reasons why you need to reduce the heat loss first. John, any question?
Yes, we got one from Andy. Do heat pumps convect warm air?
Yes, you can have the heat output of the heat pump can either be warm air or it can be hot water. You can have either, depending on what it is how you want to use it. And you can buy heat pumps. You can buy heat pumps which will directly provide hot air or warm air. Let's say you wouldn't want hot air, and these are quite common in Scandinavia. And the reason for that is the houses are so well insulated that you can put your heat pump or the output of your heat pump in your living room, pumps warm air in it, and warm the rest of the house. So you don't actually need radiators or anything else like that. So yeah, and it's much cheaper, of course, because of doing that. Historically, I worked with what was Scottish Hydroelectric some 30 years ago in installing heat pumps in the north of Scotland. And these were all Scandinavian heat pumps, which produced warm air. So we insulated the houses and then installed the heat pumps in the living rooms like in Scandinavia. Another question? You're muted, John.
Tim has asked you to go full screen with your presentation.
Oh, hang on a sec. How do I do that?
Yes, there's a little thing on the bottom of your right-hand side of the screen. If you press that, it will go full screen.
Hang on a sec. I'm going through there. Oh dear. 75. Wait a sec. Let's just have a look. Ah, right.
No, that's making the size bigger. If you want to go full screen.
Oh, hang on a sec. Yes, slide sorter. Reading view.
There's a little box. It's like a square box, like a projector screen. That's it.
That's it. Right.
Yeah.
Please. Okay. Right. So now we need to go to the next slide then. Please move this window away. Do you see that? What's happened there? Oh dear. Sorry, I've done something. Oh, this is.
You've gone on to the next slide. It's just.
Oh, I've gone on to the next slide. Yes, but
up our arrow.
Hang on a second. Previous slide. Right. Okay. Restoring radiator efficiency. Radiators are sized for central heating water of 70 degrees C. So if you're operating heat pumps at 50 degrees C, you need to restore their radiator efficiency. Now, the way you can tell whether corrosion is occurring between the central heating water and the radiators is if your radiators need bleeding or the boiler cuts out between services. So what then happens is that corrosive gases congregate in your radiators, so you only have part of the radiators being hot, and they also plate on the inside of the radiators inorganic salts. So to limit corrosion, restore radiator efficiency, you should add a small dose of inhibitor chemicals, typically 250 cc. There's the little bottle there. To maintain this level of concentration whenever your boiler is serviced. If we then go to the next slide, what we have here is an offer by a manufacturer of these chemicals called Vexo. They have a voucher scheme which will allow the first 50 people who applied to the voucher scheme. We'll come back to how you apply. You'll get this inhibitor kit, which will contain both the little bottle of inhibitor and a test kit, and you'll get a free supply for 3 years of this inhibitor. And not only will this increase your heating efficiency, it will also reduce your heating bill, and it will increase the life of your heating system. Any other queries, John?
No.
No, right, we'll move on to the next slide. Oh yes, by maintaining, sorry, we've now got this by radiating off with lower central heating, reduces the heat loss. They were existing to be reused with heat pumps and take up Vexos. There's the reference, voucher at vexopoint.com. Free supply for 3 years. Well worth.
Wayne, sorry, there was one question.
Yeah.
Do you know what proportion of UK residential properties are ready to have a heat pump installed now, i.e. those which do not require more insulation in their current state?
Well, any house built since most probably 2005 onwards will most probably be able to install a heat pump without adding any insulation. The reason for this is that until 1965, no insulation was required to be installed, not even 1 millimeter of insulation in the housing stock. 25 millimeters in 1965 in the loft, 100 millimeters in the loft in 1976. And then in 1994, there was a requirement to insulate the cavity walls and fit double glazing. And that's been successively tightened. So any house built in the last 20 years most probably will be able to fit a heat pump without having to add insulation.
If I may add something here, if you're looking for some statistics, something around 48% of the building walls in the building stock is not fully insulated to the level required nowadays, and something around 34 or 35% of the lofts are not provided with the enough level of insulation in that area. In general, it would be very conservative if we are very conservative, we can say something around 40% of the building stock needs insulation at the moment.
I would have said it's higher. There is a survey done by EDF Energy last year, which reckons that 60% of the housing stock had an insulation level equivalent to that in 1975. Now, where they get their data from, I don't know, but it's.
I was very conservative for
Yeah,
that statistic. I didn't want to go for the maximum maximum limit that reported in some resources. I just stick to the median of the result that I see,
Yes,
so
and
that I have already seen.
for example, Reading has a much higher proportion than average of older housing, and therefore a much higher proportion will need retrofitting beforehand. Right, so now,
Could I
now
just
we
ask
come-
a question on that topic?
oh, sorry, yeah.
Could either of you quantify how many kilowatts per meter squared per year would be appropriate? What level?
We'll come back to that presently when we do that. We need to go through the technology first, and then we'll come to the cost effect. So we'll answer that question. Hold off, and we'll answer that one.
I just had another question come in as well.
Yeah.
What's the best way? Oh, hold on. What's the best way to get our insulation status checked compared to current recommendations?
Oh, I'll
How's
answer
this
that
sort of-
one as well in the slide. The next steps to do
Okay.
that. Right, Mehdi, if you can talk us through the next few slides, or shall I do this slide? Perhaps
If you go ahead with this slide, I start with the
Yeah,
heat
and then you
pumps.
do the next one. Yeah. So the answer to the question is, how do you tell what your heat loss is to undertake a DIY warmth check. And there is a leaflet we've produced, which you can download from the Arcan website. The plan is to try and get Reading and Yateley. I live in Yateley. Try and get Reading and Yateley to stock temperature probes so you can actually do measurements around your house. And the other thing to do is to check what's called the energy performance certificate. And we'll give you the reference to that presently. To answer the question about heat loss, the real answer to that is given in a much simpler form than so many watts per square meter per year. The optimum is to reduce the heat loss of the building to less than 5 kilowatts as an outside air temperature of -1 C. That will enable heat pumps to be sized for 6 kilowatt heat loss. And that is really very close to the optimum for sharing heat equitably. So that's the upper limit in terms of doing it. We'll come back to the 6 kilowatts. We'll show you an example of a 6 kilowatt heat pump, which was probably the most compact, the most efficient, and the cheapest in the market in a minute. And then there is another requirement here in the conversion cost. As heat pumps cannot produce instantaneous hot water, a hot water storage tank with an indirected coil will require to be fitted if not already installed, which is an additional cost, which you would not always have to do if you have a gas boiler, which is not a combi boiler. Any questions, John, before?
John, you had a comment here saying we get a box coming up near where the titles are on the slide saying, please move this message of this window away.
Yeah, and I'm trying to figure out how to remove it.
It says that you've got a window open on top of the shared window. So you need
Yeah,
to,
now the question is, how do I close it?
You have done it.
No, have I? No.
Let's come back again.
I'm trying to. I just wish I was computer literate, you know.
If you go out of presentation mode and minimize.
Ah, wait a sec. Yes, hang on a sec.
Go back into the
Yeah. Sorry about this. I'm not. New
It's gone
share.
now anyway.
Yes. Okay. Right. So insulation requirements. Mehdi, this is yours now.
Thank you very much. One of, as Rainer mentioned, one of the first steps to make sure that the building is suitable for installation of the heat pump technologies to make sure that the building is fully insulated. One of the easiest part of the building, if it needs further insulation or top-up insulation, is loft. One single approach that you can check the level of insulation. If you go to the loft and open the hatch and have a look at the thickness of the loft, insulation in the loft. If it's less than 300 millimeters, most likely you need additional layer of insulation or replacement of the existing damaged pressed insulation with the new loft insulation. Another challenging point here is insulation of walls. Pre-1945, generally speaking, pre-1945, the construction technology was supporting the solid wall for external walls, one leaf wall, but it's changed after 1945 to cavity wall with two leaves, one internal, one external. That provides us with opportunity to add one layer of insulation in the form of board or foam or whatever between the two layers. For post 1945 buildings, when we have external wall with cavity, it's relatively straightforward to inject insulation to the cavity to increase the insulation of the external wall. Different type of insulation can be injected to the cavity of the wall, whether foam insulation or mineral insulation. Different type of insulation material can be used here. But the biggest challenge is when we have a solid wall. When we have a solid wall, we are practically have two options if we want to insulate the wall, whether to put a layer of insulation inside the building or on the external facade. Putting the inside of insulation inside the building has lots of disadvantages, including reducing the net lettable area of the building, as well as missing the thermal mass of the building that cause more rapid fluctuation and response to the heat gain received inside the building. But we appreciate that installation of insulation, adding a layer of insulation internally, it's far easier than externally, because adding one layer of insulation board or any form of it on the external side of the solid wall needs vapor barrier, making sure that the moisture is properly controlled, and needs another layer of cladding or render or different type of cladding, which is not a cost-effective approach, and it's very expensive compared to for example, if we compare it, putting one layer of insulation on the external side of the solid wall compared to the putting loft insulation in the loft. It's not comparable in terms of cost, and it is not cost effective. But there are these two options available for insulation of the pre-1945 buildings with solid wall. Another option for further insulation of the building and reducing the heat loss from the building, replacement of the single glazed windows. Again, compared to putting more insulation in the loft, this measure is expensive, but significantly reduce the heat loss associated with the building to the environment. Another very effective approach, which is not related to insulation, is using thermostatic radiator valves in order to adjust the temperature and control the distribution of the heat if we have radiator in the building. It's very effective. There are new technologies that we can use, and it's it's not invasive at all, just matter of putting a thermostatic radiator valve on the existing valve of the radiator. There are different form of thermostatic radiator valves, manual, and there are lots of other Wi-Fi connected that you can control which zone set to which temperature during which period of time in a day, in a week, in a month. These are some of the measures that can reduce the heating demand when after exercising all the possibilities for insulation, providing further insulation to the building.
John, any questions at the moment?
No.
No, right.
Before going to the next slide, for the thermostatic radiator valves, I did one experiment on a comparison of the energy consumption of an identical building with and without thermostatic radiator valves. The outcome of that case study shows that by using thermostatic radiator valves, that it can be controlled, and we can put a schedule of operation and define which time of day, week, or months that a specific radiator be in operation. We managed to reduce the heating demand up to 45% compared to the time that we haven't had that thermostatic radiator valves. And this is mainly due to the fact that most of the time we are heating the building when we are in, but we are just staying in 1 or 2 rooms, and the rest of the rooms are occasionally using the thermostatic radiator valves, provide us with the opportunity to activate the heating system for different zones when they are needed. And that's very, very environmentally supportive intervention to reduce the energy demand and consequently reduce the carbon emission associated with heating process in building.
Any questions, John?
Yes, there's a specific one. If you have a stone exterior, older church, but no room in the walls for foam insulation, are there any good options for insulation?
Is a stone both side of the wall or only external side of the wall?
Could you say that again, maybe? I didn't quite catch that.
Do we have a stone for both sides of the wall? Some of the stone buildings, building with the stone walls, a stone used out for the outside part of the wall, and inside part of the wall is kind of concrete or so on.
This is external, it says, but if it's an older church, it'll be just solid stone.
Oh, solid stone.
Yeah.
You know,
possibly a plaster on the inside. Okay.
I can imagine we have a very limited option to add insulation on the external side of the facade due to the limitation to intervention of probably very old buildings with specific characteristics and functions. But the insulation can be done inside the church. But unfortunately, that insulation inside the church reduced the opportunity for us to use the thermal mass of the building. But saying that, considering the function and the schedule of operation for a church, correct me if I'm wrong, I can imagine that it would not be, the church would not be in operation 7 days per week from, for example, 8 in the morning until 6 in the afternoon. And there are periods in the week that mostly church in the evening, or definitely in Sundays, church is in operation, and we need heating. Putting insulation inside provide us with a chance to reduce the warm-up period of the building. And especially for such functions, for example, if we use the building is occupied for example, 2 hours per day in the evening or over the weekend, by putting insulation inside, we reduce the warm-up period for getting to the set.
Maybe, can I just interrupt you? You've had a clarification. It says heavily used, 12 hours a day, 7 days a week.
Okay. Okay.
The question is, John, where is the church where you ought to go and look at it and make some recommendations rather than do that? Can whoever asked the question, is it in Reading or is it in the north of Scotland?
Minnesota, USA.
Okay.
Right. Well, I can't afford the journey, so yeah. I mean, I think we've answered the question. Need to move on because we haven't actually got the heat pumps yet. So the answer that Mehdi's given us the best, which would be to insulate on the inside. Right, Mehdi, heat pumps at last.
Yeah, heat pumps. We were talking about the heat pumps in this presentation, and I just wanted to clarify what is the heat pumps theoretically. Heat pump is a system or a technology that provides us with the opportunity to extract heat from low temperature heat sources and reject it to high temperature heat sinks. It's quite the opposite of the natural direction of travel for heat. There are different type of heat pump technology. Air source heat pumps or one of the most common type of heat pump systems that extract heat. I'm talking about the heating mode of operation when we need heating. In that mode of operation, the heat pump technology extracts heat from, for example, ambient and reject that heat to the indoor environment. It's exactly the process that happens in fridge and freezer. In fridge and freezer, we extract heat from low temperature heat source inside the fridge and freezer and reject heat to the high temperature heat sink, which is area that kitchen or whatever area that we put the fridge freezer in that area. In terms of transferring heat, air source heat pump can transfer heat from ambient to either indoor air or to a water side hydronic system to be used, for example, for radiators, fan coils, and so on, and in industrial cases for air handling unit and so on. Generally speaking, for the type of air source heat pumps that normally used in for building and for domestic buildings, there is a noise emission associated with outdoor unit. When I'm talking about when I'm saying outdoor unit is the unit that contains condenser, a fan, and a compressor of the heat pump system. And there is a noise emission associated with this external unit. Depends on the type and the manufacturer. The noise level is something around in the area of 40 to let's say less than 50 decibel A, which is not categorized as a kind of concerning type of equipment and systems in terms of the noise level. But we also have the ground source heat pump that can extract heat. If we can go to the next slide, that can extract heat from the ground. Why the ground source heat pump technology is attractive? The main motivation for going for the ground source heat pump system is during the winter when we need heating, we have to extract, for example, in January, February, we have to extract heat from the ambient with the temperature something around 0 degrees C. Heat pump technology can extract heat from that temperature, but with lower efficiency. When we move from air source heat pump technology to ground source heat pump technology. A heat pump extract heat from the ground. And generally speaking, when as a matter of comparison, comparing the air source heat pump with the ground source heat pumps, the temperature of the ground, generally speaking, 1 or 2 meters below the ground is something in the range of 10 to 12 degrees C. And you can see when we are using ground source heat pump, we are extracting heat from a source with the temperature of 11 degrees C, while we are extracting heat from air source heat pump during the winter, the temperature of the source, which is ambient, can be around 0 degrees C. And that is the main driver for an attractiveness for the ground source heat pump. This slide just demonstrates the example of how a heat pump system located inside the airing cupboard. Underneath we have the heat pump. At the top we have a storage tank. In terms of size, you can imagine the size of a very typical airing cupboard that can accommodate the installation of a heat pump system. But one thing that I have to highlight here, this example is for a 6 kilowatt heat pump system, which kind of indirectly indicates that the building is kind of fully insulated, that we are able to provide the required level of heat with a 6 kilowatt, with a heat pump system with 6 kilowatt heating capacity. Efficiency of yeah, please, Rainer.
No, I was going to say, I think at this stage we should stop and see if there's some questions, maybe. Yeah, otherwise, please. We can continue. Rather, let's answer. John?
Yes, we've got one from Andy. It says, if a heat pump is used to heat water, can it be used to cool air in summer?
Sorry, John. Cool air or water?
The question is, I think the question is slightly confusing. It says, if a heat pump is used to heat water, so there's an if clause at the beginning, can it be used to cool air in summer?
The answer is yes, as far as I'm concerned. You can't do both at the same time. You either have to, but I mean, if you have a hot water storage tank, then you can operate the heat pump in heating mode and heat your hot water to fill up your hot water cylinder. And then you can operate in the cooling mode to cool the water, for example, that you want to send round your radiators or cool air into your building. Yeah, possible.
Yes, it's possible. But one of the things that I just wanted to highlight is that combination would not be a system that we can purchase off the shelf. The majority of the systems that are generally used are either providing heat and or cooling to air or to water, but it can be simply modified by adding a kind of directive valve to feed into both air and water in indoor environment. That's possible, and there are examples of that system available.
Next question, John. It's from Christina. Has anyone found that internal space is a problem for installing a heat pump?
Can you repeat that, please, John?
It's from Christina.
Yeah.
Has anyone found that internal space is a problem for installing a heat pump? For example, many flats nowadays don't have airing cupboards because they were built for gas combi boilers, and airing cupboards in houses have been, I can't read what it is, but I think she's going to say removed.
Yeah.
But I can answer that question because of I've had quotation for heat pumps, and the heat pumps that they specified were a combined unit which combines the pump and the tank together. And I really struggled. My airing cupboard's gone. The only place I've got a basement. The only possible place would be to put it in the basement. It was just too large. But that was a 12 kilowatt heat pump. But yeah, I definitely have had that problem.
John, if I can add, Christina, the point that you mentioned is a very valid point, and it's a kind of textbook problem for installation of the heat pump that is studied in one of the latest research in 2020, published 2020, between England and Wales, on installation of the hybrid heat pump in more than 100 buildings. They outlined that one of the main issues associated with the installation and uptake of heat pump technology is lack of space for the indoor unit, and most importantly, lack of a space for the storage system accompanied with the heat pump technology. Yes, it's recorded in the body of literature, that issue associated with the space.
Can I answer that question and give a different answer? In the case of Enfield have retrofitted 6 tower blocks involving 400 flats, in which Kensa was involved in a few years ago, and they used ground source heat pumps. So one option you've got is, instead of having an individual heat pump per flat, what you have is in the basement or in the garage or wherever you've got a space, you've got one or more heat pumps of size, maybe 70 or 80 or 100 kilowatts each. And you then, all you have then is a riser, pipe riser, which supplies hot water, either to radiators or to space heating to do that. And if you take the example of the heat pump we've got in Reading at the Student Services Building, it's 2,300 square meters. It's quite a large building. And there again, you've got, I think it's 100 kilowatts of heating, which is heating this, which is the equivalent to 40 or 50 flats. So the optimum solution for flats is to have a communal heat pump system, and all you have is hot water pipes going up to your building. Other questions, John? You're muted.
No, Christina just says thank you. Very useful to know.
Well, that's all right. If you have more, if you require more information, then one can send it to you if you provide your email address. But certainly Enfield is the best known example of recent technology that Kensa have done, and they are doing this in other blocks, flat blocks up and down the country. Okay, let's.
Wait, there's one more comment from George and Heather to everyone. He's pointed out, which is quite correct, I believe. If you want the renewable heat incentive RHI grant, then no, it's not permitted under the grant terms. i.e., you can't use your heat pump for cooling if you want to get your RHI grant of £5,000.
Yeah, that's very valid. Unfortunately, the renewable heating incentive no longer exists. So for any new scheme, there is no incentive at all, I'm afraid. Would you like, Betty, can you talk us through this slide?
Thank you very much, Ryan. Yes, in terms of economics of heat pump, you know, this figure is rapidly changing by development of the technology using heat pump systems, by the market, but generally speaking, to have to get some flavor about the economics of heat pump system. When we are installing heat pump for individual houses, not like those central heat pumps for installed in communal area. When we are talking about individual houses, the cost of hot water cylinder that should come with heat pump system is something around 8 to 10% of the total cost. Installation and commissioning of the system, something around 8 to 10% of the total cost. The ground loop that extract heat from the ground, if we are talking about the ground source heat pump system, cost around again 8 to 10% of the total cost. Design 10% of the cost, and the major cost comes from the cost associated with ground source heat pump system itself and the borehole. Making a borehole to put the ground heat exchanger is one of the major sources of cost for ground source heat pump systems. In some cases, even the cost of borehole depends on the depth of the bore that we are making, can go even higher than the cost of heat pump system, higher than the cost of the heat pump system. And for the cost of heat pump system and the boreholes, we are thinking about 1/3 of the total cost would be associated with the heat pump, and 1/3 of the total cost approximately would be associated with the cost of boreholes. For the ground source heat pump systems, we have a number of arrangements for extracting heat from the ground. We can have the borehole, we can have the horizontal pipes installed on the ground. There are limitations in terms of the capacity that we can extract from the horizontal heat exchanger with the depth of 3 to 4 meters under the ground, compared to the boreholes that can go up to, normally it goes between 70 to 100 meter deep into the ground. When we are using borehole, we can extract more heat from the ground. We are reaching the cross section of the ground, and we have access to more heat from the ground. That was just a snapshot of the general economics associated with heat pump system.
John, any questions?
Yes, George and Heather came back on the point regarding the renewable heat incentive, saying that they thought that the £5,000 flat rate upwards up to £5,000, I think, is still applicable. And I think they're correct, because of I've had a very recent quotation for a heat pump, and I was told that I would be eligible for the £5,000.
Yeah, we'll come to that in a minute. It's not called the RHI.
Yeah, that's the point. Yeah,
Boiler upgrade scheme, and
Boiler,
that's where
right,
the but we'll come to that in a minute.
And we've got
Let's-
one more question as
Yes,
well.
please.
What are the considerations with designing the borehole? And I would like to add a supplementary question to that. Is there a specific minimum distance from a property?
Well, the first part is design of the borehole. If you go to a competent installer, they will know about the design of the borehole. If you take, for example, what we've done in Reading and plan to do in Reading, we've collaborated with British Geological Survey, BGS, and they are able to, like in Reading and other places, they're able to identify the strata through which the borehole will be drilled. So that will give you an idea of how much heat you can extract from a certain depth of borehole. So what your installer would do is always contact British Geological Survey first to identify the strata that's involved. The question you asked, John, was what was that again?
Is there a specific minimum distance from a building for a borehole?
No, the only distance is that which is required to get the drilling rig in, if that's the case. If you're drilling a vertical hole, I mean, the thing was probably 2 meters wide, so a meter from the building would be fine. It's a sealed system, so there's no way it can affect the foundations or anything else like that at all. So yeah.
On the topic of the BGS records, as I'm a member of the Reading Geological Society, I tend to look at the BGS records, etc. And one of the interesting things that I've discovered is that you can find they have a map online showing all of the boreholes, the records for all of the boreholes that have been dug, basically. So you
Yes.
can look around the Reading area, and it's actually quite fascinating because the records go back over 100 years, and they've digitized the records, so you can get the actual records from 100 years ago of all the boreholes that have been built. So in a place like Reading, there's quite a lot of boreholes, and looking through the ancient historical records, it's quite fascinating.
Yeah. Thanks for that. Let's go to the next.
We've got one more question.
Oh.
Just doing. We were told that boreholes, etc., are massively expensive compared to air source. Also, you need access for heavy plant. We went for air source as a result.
Well, the answer to that one is I'll answer that with the next slide. Reading, and this is important because I've done a study more than 10 years ago with a geology student from the University of Reading. Reading is underlain by a shallow chalk aquifer which contains sufficient heat, geothermal heat, to heat all 93,000 well-insulated dwellings. And the aquifer is fractured so that the groundwater flow during the summer enables the heat to be restored. The big question in Reading, but the same could apply to Yateley, which is a different strata setup, is who will be willing to supply the geothermal heat from community boreholes, because that's the cheapest option, and install the flow and return ground loops. And the answer to that question is in the final bullet. If an existing utility is not willing to supply geothermal heat, the answer is Reading will have to set up a community energy company to install community boreholes and flow and return ground loops, and they will recover their capital costs through a daily standing charge in the same way that you pay a daily standing charge for gas or electricity, you would pay a daily standing charge for heat. And then the only thing you would have to do is to pay, initially would be to pay for the installation, the purchase and installation of the ground source heat pump. You wouldn't have to pay anything for the supply side because that would be covered by doing that. So that's the solution. Of course, if you have a community borehole, so you drill 40, 50 boreholes at once, the cost of drilling the borehole comes down because you can easily drill, certainly in Reading, 100-meter borehole easily in 12 hours a day. So the answer is the cost comes down because you just move the drilling rig some 5 meters from the last borehole and drill the next borehole. So the cost comes down as soon as you get up to something like 30 or 40 boreholes. So that's the economic way to do it. And it'll come. It's the only way that we'll ever have large numbers of ground source heat pumps in the UK. Any questions at the moment?
No more questions, but I can reinforce what you were saying about questions of scale. There was a large installation put in recently, and I spoke to the contractors that put in the boreholes, and what they were saying is that the first borehole can be expensive because you never know quite what you're going into. But once you've done the first one, the subsequent ones are much cheaper. Plus, you have the cost of getting the equipment to the site, etc. So, yes, one borehole on its own can be expensive. But if you're doing a number, as Rainer says, 20 or 40 or more, then the cost falls dramatically.
And you wouldn't, all you'd have to do is pay a daily standing charge. So then the cost comes down to very close to that of a, well, much closer to that of a gas boiler. And this is the key cost slide. And I'll just...
Another very interesting question coming from Christina here.
Yes.
Does a borehole require planning permission? What's the experience like to get a borehole through the planning system?
I don't, it depends who owns the ground is the answer to that question. If you own the ground, you're able to drill your own borehole. If it's somebody else's ground, communal ground, you'll have to get planning permission clearly to do so.
Rainer, I'm not sure about that, because you may get to the water resources when we are digging 70, 108 deep, and always for going for borehole and ground source heat pump technology, it's always advised to consult with the local authority for the appropriate permissions.
It would be much more appropriate in the first instance to consult with BGS, because the thing is that depending on where you are, you can then inform the planning authority. But as far as I know, there's no planning requirement, provided you do it on your own property and it's a sealed borehole system. If you've got an open loop system, it's slightly different. I think there's multiple answers to that question. Whereas the communal borehole, you would almost certainly do this in community-owned ground, so therefore the local authority would be directly involved in this, because they would be a partner in its construction. So everything says communal boreholes with flow and return ground loops is the way to go, much more cost-effective. And this slide you need to understand, because this is critical in terms of if we're ever going to install heat pumps. So let me just talk you through it. These are the energy costs from the 1st of October, so from Saturday onwards. Gas, 10.3p per kilowatt hour, electricity. These are the upper limits. So the ratio of electricity to gas is 3.3. That's very important, because if you look at air source heat pumps, you will see the coefficient of performance, which is heat out to electricity in, varies from 3 to 3.5, but it's only 2 for hot water. So if you want hot water above that of the central heating thing, then the answer is it's much less efficient. So therefore, it will cost more than a gas boiler at the moment. On the other hand, the ground source heat pump, being more efficient, both for heating and hot water, will be cheaper than gas as it now stands. So the conclusion is the ground source has a higher initial cost, as we've discussed, Mehdi, John, and I, but a lower running cost than either air source or gas boilers. So let's have some questions.
All we've got is some clarifications from Christina, which when we were talking about the planning, she was talking about communal boreholes, which would presumably take up more space, which is correct, because we're talking about an array of boreholes here. And she also mentions the need to look out for utilities, which is obviously quite a difficult issue when you're drilling underground. As Scottish and Southern Engineering Network discovered about a year ago when they drilled underneath Reading and hit a main sewer. So yes, it can be an issue.
Christina, the thing that you should remember is that, unfortunately, I don't have a slide here, but if you looked at where the boreholes have been bored at the University of Reading, you can't see anything above ground. It's covered with a wildflower meadow. If you look at where Kensa did a communal borehole for the 400 flats in Enfield, they drilled the boreholes in the car park and then tarmacked over the car park. So the thing is, as far as use of the ground is concerned, it can be restored to its original use. So therefore, in terms of planning permission, if you're working on communal ground, and we've looked at a number of sites in Reading where we would do this, all the sites, communal ground will be restored to the condition it was originally found in, which is the reason why you won't need planning permission. In terms of finding out where utilities are, well, that's a major problem. The utilities themselves don't necessarily know where their things are. So you really need to do some discussion with them to find out where it is. Any other questions, John? We still got
I've got a very good one from Tim here, actually. So this is one that definitely ought to be covered. For ground source, what is the expected life of the heat pumps and the expected life of the ground loop?
Answer to that is 15 to 20 years for the heat pump, maybe more. It certainly is longer than that of the gas boiler because it doesn't involve a combustion process or corrosion as such. But that's the one half to the question, 15, 20 years. Life of the borehole was probably 100 years or more.
Okay. Christina has said, is anyone out there considering use an air source heat pump or a ground source heat pump, as well as their existing gas or electricity heating system? Can that be done? Asking us, I was in a house in Scotland which used central heating to top up when ASAP, the air source heat pump, wasn't making the property warm enough.
Well, you can preheat the water with a heat pump, and then if you want to heat it higher, you could use a gas boiler, but that's a very expensive solution, and I wouldn't recommend it. A much better solution is to insulate your house and install a small-sized heat pump. Mehdi, do you want to comment on that?
Thank you very much. It's another textbook questions that is very important. Yes, it's possible to have hybrid system containing gas boiler and heat pump, either of them to top up the other one. In practice, what the case studies shows, because of too many reasons, lack of proper interconnection between two systems, most likely you will be ended up with using gas boiler more than the heat pumps for heating up the building. That's due to the challenges associated with interlocking these two systems together to make sure that the heat pumps is the main source of providing heat rather than the gas boiler. But the answer is yes, it's possible if the interlocking is carried out properly.
I'd like to move on. We've got 2 more slides.
We've got one more comment from Joe Robbins.
Yes.
Who says you cannot qualify for the grant, which is the boiler upgrade grant, if you don't get rid of your gas boiler at the same time.
Yeah, that's right. And this is in this slide here. So these are the options that exist grant-wise. If you're on low income or benefits, there are 2 grant systems. There's the Eco Grant system, energy obligation, and there is the government sustainable warmth grant. That's the links for that. If you live in social housing are able to access this grant scheme. Boiler upgrade grant, that's replaced the RHI, Renewable Heating Incentive. It's a capital grant which will cover maybe 50 to 60% of your heating system, your heat pump system. And there's another option which you may or may not be aware of, that quite a large number of mortgage providers provide green mortgages. And the advantage of green mortgages is they have a lower interest rate for warmer homes. So if you're going to equip retrofit your house with insulation, install a heat pump, go back to your mortgage provider and ask them, will they supply you with a green mortgage? And if not, go on the website. There are at least 15 to 20 mortgage providers providing a green mortgage. So do follow that up if you're looking for how to pay for any upgrade you want to do. I'd like to do the last slide just because then we can have a general chit chat. So what to do next? First thing is identify the sources of the heat loss, DIY warmth check or the energy performance certificate register, reduce the heat loss, undertaking the low cost measures first. Check eligibility for grants. identify support or consider joining Insulate Together, a group buying initiative, contact Citizens Advice in Reading. The idea of Insulate Together, if there are enough people interested in insulating their houses or installing heat pumps, then this is something that could be involved in a group activity which will reduce the cost. Same applies for people in Yateley. We're putting together an initiative, Insulate Together for Yateley, and it's essentially reduce the cost. I repeat again, Vexa's free inhibitor offer, which will reduce your bills between 5 and 10%. So why not take advantage of that? And then there's a set of information leaflets which can be downloaded from the Reading Climate Action Network website. This webinar will also be recorded as well as the slides. So if you want further information, be able to consult them. So any more questions? It's been a very interesting question and answer session. And we've had twice as many questions as on Tuesday. So I'd like to thank you all for doing it. Any more questions, comments?
No more questions. I'll just make a comment about the EPC certificate. On my EPC certificate, it says that my likely consumption is 274 kilowatt per meter squared per year. But when I look at my actual usage, I'm at 130 kilowatts per meter squared per year. And I think that's because when they did the EPC, although I told them that I'd been putting in external wall insulation ever since I moved into the home, they ignored that. And they, you know, I said, well, you can drill the wall if you want. If you don't believe me, have a look. But they ignored that. So I think you have to treat these EPCs with some skepticism, because obviously it's out by a factor of 2 in the case of mine.
Yeah, I'll add a further comment. In the DIY warmth check, for which there is a leaflet, we're also I'm also talking to Reading Citizens Advice about being willing to hire out or lend out rather temperature probes, so you can actually measure the heat loss. These temperature probes cost about £20, and I'm suggesting they should purchase some of these, and you could then contact Citizens Advice, borrow this for a few days and check where your heat loss actually is. And that's most probably much better than the EPC certificate, because it'll actually measure where your heat loss is. Well, if there are no more questions, I'd like to thank you all for taking part. I do hope you'll follow up some of these things that we've done. And if you've got any further information that you can share with us, please contact us through the Reading CAN website. So thank you very much. And
Thank you very much.
It's great to have such a good discussion.
Yeah, thank you very much.
Thanks.
Not at all. I hope you've all learned something, and I will close the recording as